So I finally got the TXV installed on the heat pump, and I was running it for quite a while, and it seems that I'm getting much better evaporator utilization, especially when the water's cold. So I thought it just wouldn't work properly at all, because the refrigerant has to go all through that tube, then through a filter dryer and all the way up. But it has been working, and I will show you it in operation. I calculated the superheat by looking at the gauge temperature, then using an app on my phone called Refrigerant Slider. And when the low side was at 50 psi, the return from the evaporator, I can't remember the exact temperature, but I took a note of it and everything, and I was getting about 4.2 degrees Celsius of superheat. I think that's too low. Usually I hear videos on YouTube going on about 10 and 12 degrees of superheat, but that could be degrees Fahrenheit, I don't know. And I've also put an Arduino temperature controller on it. I've got a sensor on the evaporator return, and a sensor on the water inlet on the heat exchanger, and I basically programmed it with safety features such as frost protection and over temperature. And the Arduino I'm using is an Arduino Nano, but it's a funny kind, which instead of pins has screw-in pin headers. And I've got a 4-relay module which that is connected to, and all the DS18B20 sensors are in parallel. So here's what's going on in the sight glass. I'd say it's gotten pretty dry. The new filter dryer is working quite well. From my eyes, it seems to be matching up pretty well, pretty much about there, so it's drying up really nicely. It's doing better than the old filter dryer. So about the expansion valve, that I basically just drilled bigger, put an 8mm T-piece in it, and I've got a service valve on there, and I just use that for putting the refrigerant into the system as liquid, so it could go through the whole evaporator. And what happens next is that's the evaporator. It all comes along there through an 8mm piece of tube, and then into the evaporator there. And I thought that would probably cause problems as well, but it doesn't seem to be. I've got the external equalizer, which just comes out here. That's a piece of 6mm copper tubing. Didn't have a piece long enough, so I had to go to 4mm, and it's just in there. Also where the sensing bulb is, I glued the sensing bulb to the suction line with thermal glue, and then coated it in Armaflex insulation. I got it quite cheap on eBay, and I'll have to insulate the rest of it as well. So before, when the water was really cold, what would happen is the evaporator would just start frosting up, and start frosting down there, and then as the frost formed, the moisture in the air would freeze on it, limiting the airflow, and thus it would just get colder and frost all the way up again, and I'd end up just with a whole frosted evaporator. It still does frost up, but not so much. It takes longer to frost up now, because we're getting full evaporator use when the water's cold. So 50 psi seems a bit right on the low side for this, and I'll just have to wait until we get higher ambient temperatures. It's about 10 degrees Celsius just now, so I can find out what the temperature is ambient. I just put the sensor at the back of the evaporator. It seems we've got 10.4. I just touched the evaporator there, that's why it went down. So it's 9.7 degrees outside, and if I measure the air coming out of the evaporator, coming out of the unit, yeah, it's pretty cold. It's working really well. Earlier it was actually taking 3/4 of the temperature off. The temperature coming out was only a quarter of what it was going in, but it just all depends on the temperatures. It was a bit warmer earlier, so with the TXV it is working a lot better. So the way I play about with the superheat, I just wrote it on there, is looking down from the top of the valve, you turn the adjuster clockwise to decrease and counterclockwise to increase. So it is still frosting up. So, and if you decrease the superheat, it wouldn't frost up as much, but I don't really want to play about with it too much until I've had a chance to test it in higher ambient temperatures. Because if I decrease the superheat, so I'm just turning it just now to decrease, puts the evaporator pressure up a little bit. I'm only turning it slightly. And if the pressure goes up, obviously that means the evaporating temperature goes up. But yeah, this thing is supposed to be a 9000 BTU air conditioner, but I'm assuming that'll be 9000 BTU in certain conditions, say like when the ambient temperature is maybe 30 degrees Celsius. So that's understandable. I'm probably only getting like maybe just over 1000 watts of heat out of it, but I reckon when it gets really hot in the summer, I'll probably get at least 9000 BTU out of it. I'm hoping so anyway, but I'm going to put it away tonight anyway, because I've got work tomorrow.